Unit 11, Section 4. This is the unit circle, Part 1. Alright, the unit circle. We just want to fill out the unit circle with the coordinates and radians. Notice I already give you the degrees to start out. Now, what exactly is a unit circle? It's just a circle where the radius is 1 unit. That's why they call it a unit circle. So the only notes that you need right here is for the unit circle, you have, your normal coordinates are x, y, but for unit circle, they are x, y, but whatever x and y is, it's the same thing as cosine theta and sine theta. So whatever's x is cosine, whatever is y is sine. Okay. So cosine equals x, sine equals y, and tangent equals y. Y is on top, just like with slope and everything else. Y over x, which is also sine over cosine. Okay. So xy coordinate is cosine, sine, where cosine is x, sine is y. Tangent is y over x, which is the same as slope, right? Difference of y over difference of x, so tangent is sine over cosine. Okay. That's what you need to know down here. The rest of it is just filling out this giant circle, which we're going to use as a reference for other things later on. So I'm just going to start over here. There is a pattern, and I'm going to try and teach you the pattern. And it's all based, if you know this first quadrant, quadrant 1, the pattern just repeats on the other 3 quadrants. The only difference is you'll have some negatives thrown in there, depending on if you're going left on the x-axis or down on the y-axis, whatever. Okay, but there is a pattern. So the first pattern, I guess I'm going to start with the coordinates, the xy. Okay, so again, unit circle means that the radius is 1. So from the center right here, if I go all the way out here to this point, that would be the radius, right? So my x value would be 1 because I moved over 1, and since I didn't move up or down, that would be 1, 0. Okay, let's start with that. The next easiest one is, again, starting from the center. If I go straight up to this point, again, I didn't move left or right, so my x value would be 0, but I did move up, which is half the circle of the radius, which is 1. Notice how they are opposite. So at 0 degrees, it's 1, 0. At 90 degrees, it's 0, 1. They completely flip. Okay. Now from here, I would always start with, let's start with 1. So I'm going to start right here, and I'm going to go through and do all the x values right here, all the way to 0. Okay? That's what I'm focusing on first. And again, I'm going to try and teach you the pattern here and explain why this pattern exists, even though it doesn't look... Anyways, so starting with 1, when I go to the next one, 30 degrees, and again, I'm only doing x values, my 30 degree x value is square root of 3 over 2. Okay, going to the next one, 45 degrees. So 30 is square root of 3 over 2. 45 is square root of 2 over 2. And 60 technically is square root of 1 over 2, but because square root of 1 is 1, we just write 1 over 2. And then we get to 0. Okay, and if this would help you also, maybe it will, maybe it won't. The reason that, so we do square root of 3, square root of 2, 1, right, and then 0. But you're thinking, okay, that 1 starting out doesn't play into that pattern of going down by square roots. It actually does, because if I do, and if you want to write this, you can. This is actually square root of 4 over 2, which square root of 4 we know is 2 over 2, which does equal 1. So really, I'm starting out with square root of 4 over 2, and then I go square root of 3 over 2, square root of 2 over 2. This is square root of 1 over 2, but because square root of 1, it just simplifies to 1. And then this one, if you really wanted to do it, you could square root of 0 over 2. Square root of 0 is 0. 0 divided by anything is 0. So that is the pattern for the x values. Again, going from 1 to 0. You could also go from 0 to 1 if you want to go up. So either way you want to think about it, you can start at 0 and then go 1, 2, 3, and then square root 2, square root 3. Or I can start at 1 and go down, 3, 2, 1. Okay? Now, notice how earlier I said on the 0 degrees and 90 degrees, I have 1, 0, and they flip to 0, 1. So now look at the y-axis. I'm going from 1 to 0, which I just did, on the other way. That means that the y values for these are going to go in the same order. So if I start with 1, this would be square root of 3 over 2, square root of 2 over 2, and then 1 over 2. And actually, I just noticed something. Let me get rid of those lines because they're not negative. I don't want you to think that. So again, I go 1, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, right, which is 1/2, and then 0, which is square root of 0 over 2. So that's my pattern. Again, that's how I remember it. That's the pattern that exists. So if you can remember that, you count up from 0, 1, 2, 3, 1, and then 0, 1, 2, 3, 1. So wherever you're starting, that's all you do. Okay. Now that's the coordinates, the x, y. Remember that's cosine and sine. Now the inside, so there's this little gap right here, right? It's a little space. That's where we're going to write the radians. So radians are in pi, right? Okay, so let's start with 0 down here. So 0 degrees is 0 pi or 2 pi, depending on where you are in the circle, which is why it's also 0 and 360. So that is 0 pi and 2 pi, and then 90 degrees is pi over 2. Or, maybe this will help, 1/2 pi. So I have 0 pi, I have 1/2 pi. Now I want these three in the middle. Well, again, I'm not sure how well you understand fractions or your thinking process, and maybe you can come up with a way to remember these. I always do, okay, so half of pi, or I'm sorry, half of a half. So 1/2 of 1/2 is 1/4. Because 1/4, okay, anyways. There's different ways to think of this. So half of 90, right, is 45. Half of 1/2 pi is 1/4 pi. Okay, I always think of it that way. If you have a different way you can think of it, then do that. Okay, now we have 60 and 30. Now, again, this is just how I think of it. If you have a different way, please use that if it's easier. For 60 degrees, it is 1/3 pi. So if it's 60, I have 1 over 3, 6 and 3. And if it's 30, they flip. Now this is 1 over 6. Okay? So, again, if you can come up with a different way, use that. Another way you can think of it is if I start with 0, then I do 6, 4, 3, 2. If you just remember that order. Because again, as you're going up, those numbers get smaller. Okay, now if you can remember this first quadrant, it is very easy, or much easier to get the other 3 quadrants, because now you're just kind of doing some minor changes here and there, but for the most part, it goes together. So let me start with the coordinates, because I think the coordinates are the easier thing by far. Not that the radians are hard or difficult, they're just not as easy. Because the radians will change as you go around the circle, whereas the coordinates only change negative, if anything. So let's start with 90 degrees we have is 0, 1. So if I go back to 180 degrees, it's going to be just like 0, except I went -1 and 0. Because starting from the origin, if I go left on the x-axis, that is negative, okay? So that would be -1, 0. I'll go ahead and start with the x-axis, or I mean the x-coordinate again. So I'm going to do all of these first. And we already have from 0 to -1. So again, I always just start at the 1 and go down. You can start at 0 and go up, whatever way is easier for you. Because the 1 is negative, that means all of these x coordinates are going to be negative also. Because again, I'm going left from the origin, and for x values that would be negative. So since 1 is negative, all of these x's are negative, and then 0 is not because it's not negative or positive. So if you need to, all you really have to do is look over here. So if that is square root of 3 over 2, this is negative square root of 3 over 2. If this is square root of 2 over 2, this is negative square root of 2 over 2. And then 1/2, this is negative 1/2. And then 0. And again, the pattern still works. I start from 1, then I do square root of 3, square root of 2, 1, 0. And then going the other direction, same thing. So I want to do the y values next. So starting at 1, I can either look over here or I can just use the pattern. So 1, square root of 3 over 2, square root of 2 over 2, 1/2, 0. Now again, because that 1 is positive, the y values are also positive. So you can always refer to the 1, like the number 1 on the x or y. That determines, or that should help you if your value is negative or positive. So that's the top of the coordinates. Now we got to do the radians. Okay, radians are a little different. I'm going to try and figure out the best way I can explain this. First thing I would start with, though, is if I'm at 1/2 pi, I'm sorry, let's start at 0. So 0 pi to 1 to there is 1/2. So if I go another 90 degrees, that's another half. Well, 2 halves make a whole pi. Okay. So 180 degrees, or half the circle, is 1 pi. Obviously, I have 0, 1/2, and pi. Okay, those are easy. Now, I always start with, again, so I did the 2's, I'm going to do the 3's, and then I'm going to do the 4's, then I'm going to do the 6's. So I start with 3 next. So if this is 1/3 pi, and that's 60 degrees, right? The next one would be 120. Because if I'm going by 6's, that's 1/6, that's 2 6's. So if that's 1/3, this is 2/3. Okay, and then since 18, right, is 3 6's, that'd be 3/3, which reduces to 1. That's why it's 1 pi. Okay, the fourths. This one doesn't really work the same as the 6's or the 3's, but I think it still helps a little bit to think of it this way. Again, I think in pictures or visual really helps me, which is why I try and focus on that. So if this is 1/4, that's 45. If I double it, I get 2/4, which is 1/2. If I triple it, that's 3/4, right? Which would make this 3/4. And then another fourth over here would be 4/4, or 1 pi. Hopefully that is somewhat helping. If not, there's a lot of different ways you can think of this. There's a lot of patterns you can find. I'm just trying to teach you how I think of this and how I remember this. Okay. The last part is the 6's, right? We haven't done that yet. So again, I think of it this way. This is 1, so I'm thinking of, these are 30's, right? That's 1/3, which is 1/6. This is 2 3's, which is 2/6, right? 2/6 reduces to 1/3. This is 3 3's. 3 3's. Wow, okay. 3 3's, which is 3/6, which is 1/2. This is 4 3's, which is 4/6, which reduces to 2/3. This is 5 threes, which we don't have anything there, so this would be 5, I'm sorry, not 3. It is 5 threes, but remember, 6, which we can't reduce. And the 18 would be 6 threes, which is 6 over 6, which reduces to 1, so that works out. Okay. Now you don't need all these extra fractions that I added in here if you don't want. I don't want to confuse you. So just what's here now is exactly what you need. Uh-oh. Square root. So all the other things, I mean, may or may not help. If not, if you just want to memorize this, that's fine. If you don't want to memorize it, that's fine. You have it written down. If you're doing pre-cal next year, though, especially, you're going to need to know this because they do this in the first semester. They do a lot more detail than I do, but they start with unit circle and trig identities, which we'll get to. So you'll need to know this for pre-cal if you are doing pre-cal. If not, you'll at least need to know it for this, and then if you take SAT, ACT, or TSI, that's on there also. Okay, so we've done the top half of the circle. Now we're going to do the bottom half of the circle. So again, starting from the origin, if I go left, that is negative 1, 0. We already have that. If I go down, it's going to be 0, negative 1. Okay, those are basic coordinates. Now, without even looking at the top, I can go ahead and use the pattern and fill this out. Actually, I'll go ahead and do both sides at the same time, left and right. Go a little faster now that we've done half the circle, kind of slow. So I'm going to start over here, negative 1. So if I start at negative 1, these will all be negative, right? So negative 1, negative square root of 3 over 2, negative square root of 2 over 2, negative 1/2, and then 0. Okay, now I'm going to go backwards. I'm going to do the xy first and then move on. So negative 1, okay, that's negative. These are all negative also. So negative 1, negative square root of 3 over 2, negative square root of 2 over 2, and negative 1/2, and 0. Okay? So again, to me, coordinates are way easier than radians. Okay, on the right side, quadrant 4. I'm going to go ahead and start with the x. I'm going to do x again first. So 1 down to 0. So 1, this would be square root of 3 over 2, square root of 2 over 2, 1/2, and then 0. Now, on the y, notice how my 1 is negative, so these are all negative, right? So negative 1, negative square root of 3 over 2, negative square root of 2 over 2, and negative 1/2, and then 0. Okay, we have all of the xy coordinates for all of the degrees. Now we have to do radians. Okay, so radians, I'm going to scoot back up so we can see the radians for the whole circle. Because again, this is just how I think of it. Hopefully this helps. If not, I'm sorry. There are other ways to remember these other patterns you can look for. I'm going to start with the easy one though, 270. So if this is 0 pi, that's half a pi, that's 1 pi, right? So we have 0, 1/2, 2 halves. This would be 3 halves. And then of course 4 halves would be 2 pi, right? 4 over 2. Okay, so that's definitely the easier one. Then I'm going to go ahead and do, I guess we can do the 3's like we've been doing. So for 3, okay, the 1/3 pi is 60 degrees, so that's 1/6. This is 2 6's. Then we have 3 6's, right? So 3 6's is 3 over 3. Now, 4 6's, 6 times 4 is 24, which would be down here. So this is 4 6's, so this would be 4/3 pi. 5 6's would be 30, so it'd be 5 over 3 pi. And then 6 6's is 2 pi, because 6 over 3, right? Okay, so that works out. So that's the 3's. So I'm going to erase those. 4's. So we have, this one's just visual. That's 1/4, 2/4, 3/4, 4/4. Okay, notice how these are all in the middle, so it makes it, that's why visually this is easier. So it's 1, 2, 3, 4. Then we have 5/4, 6/4. This would be 7/4, and then 8/4 is 2. And then we're back to where we started. Awesome. Okay, last one is 6. Again, if you like to do the by 30, we have 1, so 3 times 1, which is 1/6, 2, this is 3, which I still have there, 4, 5, 6. Now we go down here, 7, that's 7 threes, so 7/6 pi. This is 8, which we already have, 9 we already have, 10 we already have, 11, so 11/6 pi. That's why I go in that order, because if you already have a number there, a radian listed, then you don't have to do anything. You already have the answer. You're just trying to find the few that are missing. So again, that's the order that I do this in, and I do this from memory every time because I don't want to forget. I'm not expecting you to memorize it. That's okay. I totally understand. But now you have the full circle. We're going to use this circle to answer questions. Okay. Now, if you can, it'd be interesting to try to do this by memory. That'd be fun. Or if you like math, that might be fun. If not, that's okay. All right, so the second part of today is just using the unit circle to find the reference angles and the exact value for the trig function, okay? So I'm just gonna, so the unit circle we have on the last page, we're gonna go ahead and look up these values and just write the value. Pretty easy. So I want sine of 30. Now, if you, from the notes up here, right, remember, sine is y, cosine is x. So we have sine is y, cosine, theta is x. Tangent, if you'll see that on the homework, tangent would be y over x. And notice on number 3 I have secant, so we're bringing back those other 3 trig functions we didn't use yesterday. So secant would be a cosine flipped. So if I have secant, that would be 1 over x. Okay. And if I have cosecant, that'd be 1 over y. And if I have cotangent, that would be x over y. Okay. And again, for the cosecant, secant, cotangent, if maybe this will help you, it'd be easier. You can just write, flip y. Secant, I want to flip x. Cotangent is really nothing to flip because it's not just a number you can flip over like x and y. Cotangent, I'm just going to leave like that. You're just going to write whatever the x is divided by whatever the y is and then simplify from there. Okay, so let's do one of these problems, or both of these problems. So sine of 30 degrees. Well, let's start off with 30 degrees equals what coordinate? Well, if you look at the unit circle and you find 30 degrees, I guess I will show you how to use this if you aren't sure. Okay, so here's 30 degrees. All right, here's x, here's y, and I want sine. Okay, sine of 30. Well, I found 30 degrees. Sine is y. It's just 1/2. That's all I'm doing. So I guess I don't really need that. So sine of 30, I can just put 1/2 because I have the unit circle to tell me that is the answer. And there's nothing else to do for that one because it's one of the 3 main, or I guess sine, cosine, is just x or y. It's a single number. I don't have to do anything else. So sine of 30 degrees is 1/2. Now secant. Secant is a little different. Secant, if we go down here, means is I want to find x and flip it. So whatever x is, I flip x, and that is secant. So I want to find secant of 5 pi over 6. Okay, so let's go to the unit circle. Since we have all this labeled correctly, right? 5 pi over 6 is right here. And secant, or, I find x and flip it. Here's x right here, negative square root of 3 over 2. Okay, so I want to flip that. So if it's negative square root of 3 over 2, let's go down here, or if you're flipping your page, I'm going to have negative, it is negative square root of 3 over 2, but I want to flip it. It's negative 2 over square root of 3. Now, the only problem is because I cannot have a square root in the denominator in the bottom, I have to rationalize the denominator. We've done this before. It's just been a while. So if you flip your fraction or flip a number and you have a square root in the bottom, all you do is simply multiply by square root of 3 over square root of 3. Or if it's a square root of 2 or square root of 5 or whatever the square root is, you just multiply top and bottom. Okay, why would we do that? Okay, this would give me on top 2 times square root of 3 is 2 square root of 3. Remember, I can't put those together. Over square root of 3 times square root of 3. Because they're both square roots, I can do 3 times 3. I get 9. Now I can reduce that though, right? Because I know square root of 9. So my answer would be negative 2 square root of 3 over 3. Now if you could, I can reduce 2 and 3. You can reduce outside numbers, but those do not reduce, so that would be my final answer. And that's how you do reference angles using the unit circle. So you just find your x or your y, or if it's tangent, you would divide them. And either you just have a simple number, like number 2, or you have something where you flip it and you got to rationalize the denominator for number 3. Please definitely practice this, because I know this is probably brand new. You don't do this in Algebra 1, you don't do this in geometry. That's it.